Hello everyone, I'm Sam, and my fellow group members TJ and Brian will also be speaking throughout the video. For our senior project, we were tasked with developing a blood oxygen imager by our extremely helpful advisor, Dr. Hao Zhang. I'm very pleased to introduce SPOTO, which stands for Scanning Projection Optical Tomographic Oximetry. To clarify the significance of the name SPOTO, I'm going to break down each part. S is for scanning inside the object, P for the projection of an image onto the sensor array, O for the optical properties of light rays, T for the tomographic form of data collection, which provides an image of the cross-section of an object, O for oximetry, which is a measurement of blood oxygen. So why is SPOTO significant? Well, I will answer this question momentarily. Some current products relative to blood oxygen imaging include an egg cannula, which provides an anatomical visualization of the vascular system and no functional data. An oximeter, similar to the one in your smartwatch, can gather functional data of blood oxygen but does not display any image. Finally, a CT scan, which is a medical imaging technique that is unable to gather blood oxygen data and utilizes damaging radiation. Now back to my previous question. The significance is that none of these products can produce a 3D image of blood oxygen. But by combining the advantages of each technique, we developed SPOTO. So what can SPOTO be used for? Well, it could detect birth defects or deficiencies in fish embryos by collecting the blood oxygen data. It also can provide data regarding meat quality and freshness based on the amount of myoglobin it is releasing. And finally, it can monitor developing avian embryos.
So when we were first assigned this project, we wanted to establish two goals right off the bat, one for each semester, the first of which was to develop an automated process and system that would produce a 3D image of a semi-translucent object with just visible light, and the second of which was to incorporate infrared light to produce a 3D image of blood oxygen of some kind of biological material. We were able to accomplish the first goal pretty easily, but the second one we were unable to accomplish due to the COVID-19 closures of our campus. So in designing the actual setup, we had quite a few things that we had to consider. Some examples of this was actually our setup type, and so we had to choose between rotating just the object or rotating the entire setup around the object. We opted to rotate the object. Another example was the actual motor that we chose to actuate this process, and for this we opted for a stepper motor over a servo motor due to its higher functionality. A big constraint that we had was the budget that was established by the department of $500. So for our first prototype, you can see the objects actually rotating right now. It consisted of just three components, and that is the light source, the object with the motor, and then the actual camera or sensor array. And with this first prototype, we tested two different type of Lego pieces, the first of which was a simple cylindrical piece. They came out with a pretty decent image. It's a little crooked, but still pretty good. And then the second object that we chose was a more complex crystalline type of structure, and our prototype was unable to get the actual definitions of some of the intricacies.
We moved on to a more complex setup utilizing lenses to create a parallel beam from the light source to the sensor array. We also used a container that was acrylic filled with water to limit diffraction. We then designed and 3D printed a track and sliding pieces for each component to align everything and create a straight line from the source to the array. So the issue with this is that it ended up having way too much noise, and that would be because the alignment wasn't correct with the 3D printer or the cheap lenses and container, which could have had impurities. But the most important takeaway is that the MATLAB code was combined into one. So a push of the button would take the image, rotate the object, and process the data into models that you can see before you. So in the final setup, we went down to one lens, and you can see the actual setup on the photos on your right. And from this, we were able to obtain a really quality image with minimal noise, and saw that the most important aspect is actually image processing techniques and being able to tinker with the filters built into the MATLAB code. Before we were sent home, we had bought an optical grade track and machined aluminum sliding pieces to create better alignment, which would have led to less noise and better images. But unfortunately, that never got used. And we would have liked to incorporate infrared light to penetrate objects such as meat or an egg to get an image of the inside of them. But in conclusion, we found out that it works, and we really just need more time and more knowledge of image processing to get it done. So feel free to email us or Dr. Lancina if you have any questions. And thank you from SPOTO for listening.